Hi to you all. This video is my overview concerning the difference between using supervised and unsupervised method to train a neural network, as I did in my first video, and to be relevant and make an overview that maximum of people can understand. I will start by announcing the keywords I will use in this video. Neural networks, supervised and non-supervised method, convolutional layer, the first, the last, and what's between, activation layer. So let's start with neural network, where every neural had an activation level xe between 0 and 1. A neural network is made of layers, and more specifically, convolutional level, as we had seen in the last overview. So, for example, to calculate for a neural E, for the first layer, the activation layer would be xe1. Then we have to distinguish supervised and non-supervised method. The difference is simple. With supervised method, we label or tag the output, while on the non-supervised, we train the neural network to predict the output, or in other words, learn probabilities distribution quickly specified binary. So why non-supervised method are today used instead of supervised one? Let's first give a brief description on how it works with this method. For example, we want a system that can recognize images, whatever, fruits, faces, which is the input to the system. Every image is made of pixels. For example, black and white image would be X pixel, and in output, we have G possibilities. For example, it could be an apple, a banana, whatever. So to activate a neural, we use the activation function phi. Xe n plus 1 equal phi, the sum from E equal 1 to K, WEG XEN. XG n plus 1 means it's for the layer n plus 1. Phi is the activation function, and WEG is the synaptic weight between the neuron E and G. So as we can see, each layer depends on the previous one, except for the first one, XE1, which represents gray level proportion of the image used as the system input. The activation function phi is a sigmoid function, which in mathematics means it's an increasing function, differential, nonlinear, and phi x has x between 0 and 1. We use mean squared error function, CMSE, to reduce the gap between what is expected and the output we get. C is a function of cost. In mathematics, it is defined with C x W equal the sum from G equal 0 to 9 of the difference between Y Gx and TG. What we get and what we expect. Let's consider CMSE mean squared error of the synaptic weight equal the sum of x belonging to epsilon of CXW. The goal is to reduce the sum using what we call stochastic gradient descent that aims to approximate the gradient and the gradient of CMSEW and CXW. Considering X random input used for neural network epsilon, but it has been revealed that this algorithm called retropropagation is time-consuming and suffers from other overfitting. Overfitting is what happens when we overuse layers and neural while training a neural network. training neural network had laid on supervised technique for a long time until non-ones could be applied, used RBM, Restricted Boltzmann Machine, where we have a generative model that allows us to build a neural network capable of learning, then generating simultaneously images and labels X and Y with the probability of distribution close to this observed in training dataset, the specified entry. So to build a generative model, we use DBN made of two main parts. DBN is Deep Belief Network. So it's made of two components. The first one is the compression layers. The second one is the conversion layer. In the first one, we have a bunch of layers. It is used to convert input X in an abstract representation. And in the second, it's one layer. It is used to convert abstract representation into classification label Y. So all things considered, RBM used in the compression phase is the component that made all the difference, and the main characteristic expected from this component is ability to learn quickly a probability of distribution specified by an entry. For example, an image. RBM is made of visible layers and hidden ones. In math, it is defined by distribution of probability conjoint. P VH equal exponential of minus EVH divided with Z, as you can see in the figure, where the energy of activation of the VH is the sum from 1 to K plus the sum of G equal 1 to 9 plus the ponderation between the two of them. The Z constant guarantee that this probability is a probability distribution. So in this overview, I've tried to be very minimalist so I can give you the difference between the non-supervised and supervised method. Thank you, and God bless.